An element atom with added neutrons is called an isotope. So here we have a picture of hydrogen, and hydrogen has two isotopes. So this is the hydrogen that we would normally see on the periodic table. It's the one that we know it has one proton and one electron. But it can have an added neutron, and then it's called deuterium. And if it has two added neutrons, it's called tritium. So deuterium and tritium are two known isotopes of hydrogen. So this is why elements will have an atomic mass number that isn't always a whole number. So if you notice that on the periodic table, when we look more at that, it doesn't always have a whole number. And that's because what they've done is they've taken an average and they have to use the isotopes and the percentage of isotopes in the environment to get an atomic mass number, or to get the weight. That's the average. So people are kind of like elements. Our weight can fluctuate. Some years it's a little higher, some years it's a little lower, maybe after Christmas it's a little higher. But it doesn't change who we are. It just means, well, we're just looking maybe a little different. Our physical properties may change a little bit. But we remain the same person even if we've added a little extra weight. Okay, and now we're going to end this video watching a video from Fuse School on radioactive isotopes.
This lesson looks at why some isotopes are radioactive. You may wish to refer to the lesson Why Aren't All Atomic Masses Whole Numbers to help you understand this video. The identity and chemical properties of any atom are determined by the numbers of protons in its nucleus. As atoms get bigger and heavier, the nuclei get bigger and heavier, and the protons need a sort of nuclear glue to help hold them together. Neutrons provide this glue and prevent the positive charges of protons from repelling each other, thanks to something called the strong nuclear force. Elements can exist with slightly different numbers of neutrons, and we call these isotopes of an element. It is particularly common for heavier elements where a lot of neutrons are required to hold the nucleus together, but smaller and lighter examples include the isotopes of hydrogen. Hydrogen 1, hydrogen 2, also called deuterium, and hydrogen 3, also known as tritium, are the three isotopes of hydrogen. They have 0, 1, and 2 neutrons respectively. Tritium is the heaviest isotope of hydrogen as it has a larger mass number. Note that in each of these isotopes there is a single proton. And this means that the element is unchanged, and that's the important point. It is still hydrogen and will react chemically in exactly the same way. There is often more than one stable isotope of an element. In fact, much of the world around us is made up of stable isotopes. However, sometimes there aren't enough neutrons in a nucleus, or there may be too many for it to be stable. An analogy is a person carrying boxes. If you try to carry too many boxes, you'll end up dropping some. And if you continue, you'll keep dropping boxes until you reach a manageable amount. This is your stable state. And nuclei behave in a similar way, and they will try to stabilize themselves. If there are too many protons or too many neutrons, the nucleus can spontaneously rearrange itself and throw out particles in the process. This is essentially what happens in radioactive decay. Isotopes that have unstable nuclei like this are known as radioactive isotopes or radioisotopes. In our hydrogen examples, tritium are unstable and are hence radioisotopes of hydrogen. The more unstable a nucleus, the faster it will try to rearrange itself into a more stable state. And another name for this process is radioactive decay. Radioisotopes are often used in medicine to trace aspects of body chemistry or blood flow. For example, a small amount of the radioisotope technetium-99 may be injected into the bloodstream to show up on medical imaging and X-rays, and this is known as a medical tracer. Tracers can be used by chemists to understand how a reaction works. Atoms of radioisotopes can act as markers, allowing chemists to follow how a reaction sequence occurs. And of course, radioisotopes are also used in radiotherapy to kill malignant cancer cells. So, as you can see, isotopes are important in modern science, and so we'll finish with a summary of the key points. Isotopes of the same element have the same chemical properties. Some isotopes are stable. Isotopes that are unstable are radioactive. Radioactive isotopes are also known as radioisotopes. Radioisotopes can be used as tracers or markers in chemistry and medicine, and they are also used to kill cancer cells.